quite a common question that crops up in exams is you're given the question that asks you how many bits do you need to represent a certain number of items. So let's just use an example of this. So the question that we've had in the past, they've asked you how many bits do you need to represent all the lowercase letters of the alphabet. So we know that there are 26 letters, so we have 26 items. So how many bits do we need to represent that? Now we know that one bit will not be enough because one bit we can only represent two values. So if we think of it this way, so if we think of it as number of bits and number of values. So if we have one bit, we can represent two values, 0 and 1. If we have 2 bits, we can represent 4 values, 0, 0, 0, 1, 1, 0, and 1, 1. If we have 3 bits, we can represent 8 values. So the relationship, of course, is, well, that's 2 to the 0, to the 1, sorry. 2 squared, that's 2 to the 3, and then if we have 4 bits, that becomes 16 values we can represent, so that's 2 to the 4. And then if we have 5 bits, we can represent 32 different values, which is 2 to the 5. So what we're saying is we actually need 5 bits to represent all the letters in the lowercase letters in the Latin alphabet, so 26, because the number of values we can have with 5 bits is actually 32. 4 is not enough, 5 is more than we need, but you can't obviously have a fraction of a bit, so we have to take the higher value, so 5 here. So we need 5 bits to represent 26 different values of the alphabet. If we were to say we want to represent both the uppercase and the lowercase values, so we now have 52 items, then we'd have to increase the number of bits to 6, because we have 6 now, so the number of values we can have is 64, which is 2 to the 6. So depending on the number of bits we have, we can actually determine the number of values we can have to represent our items.